welcome to the Bare Metal Cyber SIEM Prepcast. This series helps you prepare for the exam with focused explanations and practical context. Incident management is not just about policies, plans, or personnel. It is also about the tools and techniques that enable response teams to work faster, smarter, and more effectively under pressure. The purpose of using incident management tools is to automate repetitive tasks, improve the speed and precision of response efforts, and give security teams clear visibility into what's happening across the organization. From detection to containment to reporting, tools support the full lifecycle of incident handling. They help teams detect anomalies in real time, investigate the root causes of security events, and coordinate actions across different teams and environments. Tools also improve collaboration by providing shared dashboards, integrated communications, and automated workflows. And perhaps just as important, they ensure that incidents are documented consistently and completely, creating a reliable audit trail that supports compliance, post-incident review, and strategic planning. In high-pressure situations, tools don't replace human judgment, but they do enhance it by surfacing the right information at the right time and enabling repeatable, structured response actions. Incident management tools fall into several core categories, each supporting different stages of the incident lifecycle. Security information and event management platforms, often referred to as SIEMs, collect, aggregate, and analyze logs from systems across the environment. SIEMs are essential for identifying unusual behavior, triggering alerts, and correlating activity across endpoints, networks, and cloud platforms. Security orchestration, automation, and response tools, known as SOAR platforms, sit on top of SIEMs and other tools, enabling security teams to build automated playbooks, streamline workflows, and coordinate multi-step response actions. Endpoint detection and response tools, along with extended detection and response platforms, focus on individual devices and their interactions. These tools allow analysts to detect malware, privilege misuse, or lateral movement by tracking endpoint activity in detail. Threat intelligence platforms provide additional context, enriching alerts with information about known threat actors, tactics, and indicators of compromise. And case management or ticketing systems allow teams to track incidents, assign actions, record status changes, and analyze trends across incidents over time. Each category addresses a different layer of the response challenge, and when combined effectively, they create an integrated ecosystem that supports rapid detection, structured response, and strategic oversight. The most effective incident management tools share a set of common features. They must be capable of real-time correlation, connecting signals from various sources to form a coherent view of an event. This allows analysts to identify coordinated attacks or systemic issues rather than viewing each alert in isolation. Integration is also essential. Tools must work seamlessly with existing infrastructure, including firewalls, identity and access management systems, cloud platforms, and endpoint protection software. Customization is another critical feature. Analysts must be able to tune alert thresholds, write custom detection rules, and define automation logic that reflects the organization's unique risk profile. Automation is a key value driver, especially for repetitive tasks such as isolating a host, disabling an account, or running enrichment checks on a suspicious IP address. Tools must also support role-based access control to prevent unauthorized use and maintain clear separation of duties. Finally, strong audit logging must be built in, allowing every action to be tracked and reviewed during incident analysis or audit processes. These features ensure that tools enhance, not hinder, the response process. For more cyber-related content and books, please check out cyberauthor.me. Also, there are other podcasts on cybersecurity and more at baremetalcyber.com. Supporting detection and investigation is one of the most important functions of any incident management tool. Advanced detection capabilities rely on behavioral analytics, which use statistical and machine learning models to identify deviations from normal activity. These tools don't just look for known bad signatures, they detect suspicious behavior even when it hasn't been seen before. For example, an employee logging in from an unusual location at an unusual time, combined with large-scale file access, may trigger an alert. Investigation tools must provide advanced search functionality, allowing analysts to query logs, endpoint telemetry, or network flows to trace suspicious behavior. Integration with threat intelligence is essential at this stage, adding context such as known bad IP addresses, malware hashes, or recent campaigns targeting similar organizations. Visual tools, such as timelines or attack graphs, can help responders reconstruct the sequence of events, understand the attack path, and determine which systems were affected. Alerts should be prioritized based on severity, business impact, and context, helping analysts focus on the most critical incidents first. Incident response coordination improves dramatically when tools are used to unify visibility, task management, and communications. Incident dashboards provide a real-time view of incident status, who is assigned to which task, and what stage of the response is currently active. This visibility is crucial for team leads and executives who need to understand the situation without disrupting operations. Built-in communication channels or integrations with tools like Slack, Microsoft Teams, or email platforms help streamline coordination without relying on ad hoc conversations. Task assignment and escalation workflows allow responders to assign specific actions, set deadlines, and escalate when needed, all within a centralized system. Checklists and embedded playbooks provide structured guidance, helping responders follow a predefined sequence of actions based on the type of incident. Notifications can be sent automatically when thresholds are reached, for example, when an incident is classified as critical or when external reporting obligations are triggered. This coordinated approach ensures that nothing falls through the cracks and that teams remain synchronized even in chaotic environments. Automation and orchestration are not about removing human judgment. They are about optimizing response by reducing manual effort and minimizing delay. Many incident management tools allow initial triage steps to be automated. For example, when a phishing email is reported, the system can automatically search for similar messages, identify affected users, and check IP reputation scores. Predefined playbooks can be executed in response to specific alerts, such as launching malware scans, disabling accounts, or isolating endpoints from the network. Automation can also be used to perform containment actions, such as blocking IP addresses at the firewall, updating threat feeds, or notifying relevant stakeholders. These actions can be chained together across multiple tools. A detection in the SIEM can trigger a workflow in the SOAR platform, which then updates access controls in the identity system and sends alerts to the communications platform. This not only reduces response time, but also reduces analyst fatigue, allowing human responders to focus on complex analysis and decision-making rather than repetitive tasks. To maximize value, incident tools must be fully integrated into the broader security ecosystem. Integration with vulnerability scanners allows incidents to be correlated with known vulnerabilities, helping prioritize remediation and identify risk trends. Syncing with identity and access management systems supports rapid response to user-based incidents, such as disabling access or reviewing privileged use. Integration with governance, risk, and compliance platforms enables documentation of incidents, risk scoring, and reporting across compliance domains. Some tools also support bi-directional sharing with threat intelligence exchanges, allowing organizations to contribute to and benefit from community insights. Finally, integration with compliance management platforms helps ensure that all incident documentation is captured, retained, and reported in accordance with regulatory requirements. This kind of ecosystem-level integration ensures that incident management is not an isolated function. It becomes a core component of the organization's operational and strategic risk posture. Selecting the right tools begins with understanding your environment and requirements. The first step is to assess how well potential tools align with the organization's existing architecture and primary threat concerns. A tool that excels in one environment, such as an on-premises data center, may not be effective in a highly cloud network organization. Vendors must be evaluated not just on functionality, but also on their ability to scale, their level of support, and how well they integrate with other components in your environment. Both technical and operational stakeholders should be involved in the selection process, including security analysts, IT administrators, compliance officers, and incident response leads. Key criteria should include usability, customizability, and alert accuracy. Complex tools that are difficult to configure or prone to false positives can do more harm than good. Proof of concept testing should always be conducted before committing to a full deployment. This allows your teams to validate the tool's features, test its integrations, and ensure it supports your operational workflows. Deploying tools is only the first step. Operationalizing them requires procedures, training, and ownership. Each tool must have clearly defined roles and permissions, both for daily users and for administrators. Playbooks must be developed for each use case the tool is expected to support, such as credential theft, ransomware containment, or email phishing. These playbooks should be tested regularly and updated as systems or threats change. Analysts and responders must be trained on both the technical use of the tools and the procedural steps that tools are intended to support. Escalation processes and cross-team handoffs should be documented clearly to avoid delays during response. Tools should also be included in red team exercises or simulated attacks, so their real-world performance can be evaluated. These simulations help uncover configuration errors, permission problems, or visibility gaps that may not surface during routine operations. Maintenance is critical for ensuring that tools continue to deliver value over time. Alert rules must be tuned regularly to reduce false positives and sharpen detection accuracy. As new systems and services are added to the environment, tools must be reconfigured to maintain coverage. System performance and uptime must be monitored as part of service-level agreements to ensure reliability. Playbooks must be updated as threats evolve or as internal processes change. User feedback should be collected and analyzed to identify workflow bottlenecks, confusing interfaces, or integration challenges. And all of this must be aligned with broader incident response metrics and program goals. If tool performance is not contributing to faster response, better detection, or improved coordination, changes must be made. The goal is not just to have tools in place, it's to ensure that those tools meaningfully improve the organization's ability to prepare for, respond to, and learn from security incidents. Thanks for joining us for this episode of the Bare Metal CyberScience Prepcast. For more episodes, tools, and study support, visit us at baremetalcyber.com.